In this video, we're going to talk about some of the triangle similarity theorems. Now remember, these theorems, right, are going to be, eventually we're going to be using them in proofs, and since they are triangle similarity theorems, these theorems are going to be used to prove that two triangles are similar to one another. Now again, these theorems are always used as our reasons in proofs. So whenever you're doing a two-column, which we're not going to do just yet, but just know that these are theorems that you are adding to your reasons bank. So recall, when two triangles are similar, we know that all corresponding angles are congruent, right? And then we also know that corresponding sides are proportional. So this is just going back. We got to make sure we're keep drilling this definition because it helps us make some conclusions and it helps us answer some questions. So there are three triangle similarity theorems. Now you have to understand and know the difference between triangle congruence theorems and triangle similarity theorems. So for triangle congruence theorems, there were 5 of them. Triangle similarity theorems, we have 3 in total. So as you guys are taking your notes, you need to make sure that you are listing all 3 of these out, drawing the pictures, and writing in what these theorems say or what they represent. So the first theorem we're going to talk about is the most common one that is used. That is angle-angle similarity. So again, these letters usually tell you exactly what you need. So AA stands for angle-angle. And that means that in diagrams, we have 2 corresponding angles that are congruent. Now remember, these similarity theorems, similar to congruence theorems, they are shortcuts. So if you have a problem, right, instead of going back, right, instead of having to prove all 6 of these things, right, instead of having to show that to say similarity, these theorems are shortcuts. So our shortcut number 1 is if we have 2 triangles and we can conclude using our prior knowledge or using givens, if we can conclude that 2 pairs of angles are congruent, then we can automatically conclude similarity. So angle-angle is the one that's most commonly used, and to be honest, it's the easiest one. There's only 2 conditions. If you have 2 corresponding angles that are congruent, you can go ahead and conclude that those 2 triangles are similar. Now, these other 2 theorems that we're learning about are also congruence theorems, so you need to understand the difference. So the second one is side-side-side similarity. So SSS similarity. Now for congruence, what this said was, hey, if all 3 sides of one triangle are congruent to 3 sides of another triangle, then we have congruence, right? But now we're dealing with similarity. So we're not dealing with congruence anymore. We're not dealing with these 3 sides being congruent. We are dealing with them being proportional. So remember, when 2 sides are proportional, there's usually a scale factor, right? So how to break down this diagram is that we have 3 sides. We have triangle A, B, and C. Now, to get to this triangle, there is some scale factor that we're multiplying by. And in this case, we're saying that scale factor is k, right? So k can be whatever number. It can be 1, 2, or 3. So that means that this side is that scale factor times our original side, right? This side here is going to be our scale factor times our side B. And then this third side in orange is our scale factor, which is k, right, times our side C. So again, side, side, side is not saying that 3 sides are congruent, but it's saying, hey, if all 3 pairs of sides are in proportion to one another, then we can conclude similarity. Now, it's important to know the explanation of these theorems because on a test or a quiz, you guys might be assessed on just matching theorems to their definitions, right? And then last but not least, we have side, angle, side. So again, we're dealing with 2 sides and an included angle. Just like it was for congruence, right? Remember, included angle means that that angle needs to be directly in between our 2 sides, right? So, but instead of having those 2 sides congruent, we have those 2 sides being in proportion, right? And then that included angle is congruent. So in this example here, we have side A, and then we have here k times A, right? And remember, k is our scale factor. And then we have side B, and then we're multiplying our scale factor by side B to get k times B, right? So this tells me that both of those sides are in proportion. Now our third condition is that that angle right in between would need to be congruent, right? Included angle, that is super important. If your angle was anywhere else, right? Like let's say we didn't have this information. If our angle was here, then we cannot use side angle side similarity, right? And again, remember, these are all shortcuts. If we have, and these are three completely separate cases, if we can use any of these three shortcuts, then we can conclude similarity, right? That's the goal here. So those were in words. These are kind of math symbols, right? So angle, this one's a little bit easier, right? If A is congruent to D and B is congruent to E, then we can conclude that triangle ABC is similar to triangle DEF. For side similarity, this one's a little bit different, right? We've used words of scale factor and sides being in proportion, but you guys have to be able to digest something like this, right? If you are given something like this in a question, what this is saying, right, how to break this down, even if you're given just something about like two of them, right? These proportions tell you that sides are proportional. Right, so to break this down, right, we have AB over DE equals BC over EF, right? So what this first part is telling me is that AB and DE and BC and EF, there's a scale factor there. Right? They're proportional. There's going to be a number that I can multiply one of the sides of a triangle by to get to the other one, right? So get in the habit of identifying this, because there might be multiple choice questions that give you certain information and they'll ask you what theorem you can use. You guys just need to be able to recognize that this means certain sides are proportional. Now, since all three sides are listed in this proportion, we can use side to conclude that our two triangles are similar. Now, side angle side, again, we have two corresponding sides that are proportional now, and the included angle needs to be congruent. So this is another good example of being able to kind of digest these fractions given to us. So I usually like to highlight based on what the fraction says. So for example, it says AB over DE is equal to AC over DF, right? So if we highlight that, it helps me see exactly which pairs of sides we're talking about. And then this says if angle A is congruent to angle D, remember for side angle side, your angle needs to be included. It needs to be directly in between or touching both of the sides that we have information about. So the main idea of this slide is just being able to kind of digest what these proportions are saying, right? And it helps to highlight your side so that you can see exactly what we have here, right? Because if we had something like this, right, let's say we had AB over DE, but then we had AC and EF, right? Those are two very, very different things. So sometimes highlighting will help us here. Now, prior knowledge, remember, if we're given information about parallel lines, we should be looking for our alternate interior angles, and those are our Z angles. So just a good thing to know, and I would write this in our notes as well, when given parallel lines, if our diagrams look like this, we're going to be using Z angles. But then our F angles is something we haven't really studied that much in terms of triangles, but these are our corresponding angles, right? So remember, and we can also use, this is the circle theorem or the circle method. Some people like using the circle method here where you make circles and you kind of like bottom right of this circle is equal to the bottom right of that circle. Some people like doing it that way, and if you do, then that's totally fine. But just drawing this diagram next to this, right? And again, in this diagram, we would have that the very top line and the bottom line are parallel, then we're going to be using our Z's. In this case, when we have when we have diagrams that look like this is when we're using the F angles or the corresponding angles or that circle method, right? So just to give you a better idea of highlighting what you're looking for, right? In this diagram, you might have a Z like this, right? Or also going backwards. And then in this diagram where you kind of have triangles within one another, your F's are going to be kind of like upside down, right? So that would be like this angle, and then this angle, this angle. So these are just general ideas. If you have triangles that kind of look like this, you're gonna more generally be using the alternate interior angles. When your diagram looks like this, you're going to be using the corresponding angles. Now remember, you can't make these conclusions unless you are given that the lines are parallel, but I just like having these as kind of set points. Like having this in your notes, you know that if your diagram looks like this and you have parallel lines, you should be using your alternate interior angles, right? And this helps in proofs as well. And then if your diagrams look like this, then in your theorems, you're going to be mentioning corresponding angles in there somewhere. All right, here's some practice. So are the two triangles below similar? So let's see what we got. I'm just going to highlight some things. So we have AB and BC, and then we have DF and EF. We're given information about those two, right? We have this angle here is 80 and this angle here is 80, but what I'm seeing right now, I notice that there's a scale factor of 2, right? If I multiply 2.5 by 2, I'll get 5, and then if I multiply 3 by 2, I'll get 6. But we can't use, my first initial thought, maybe we can use side angle side similarity. But we cannot use side angle side similarity because the angle, the congruent angle, maybe we'll say, the congruent angle is not directly between our two sides. Don't get tricked. People might be like, oh, we have a side and angle and a side. Yes, we can use SAS similarity. No, the angle needs to be directly in between or directly touching our two sides. In this triangle, we're good, right? Our angle is it's touching our two sides we have info on, but here it's not. Here, our angle is only touching side AB. It's not touching side BC, right? So what we could have done, right, or if we did have this information, let's say instead if the 80-degree angle was here, then we'd be good. But in this case, it is not. So we cannot prove that these two triangles are similar. Now, don't forget, we always also want to get in the habit of looking for drawing our triangles separately and seeing if they share an angle or share a side, right? So here, I'm going to draw my larger triangle first. This is triangle BAC. We want to make sure we're carrying any labels over. And then this one is going to be our smaller triangle, which is EDC. Carrying over any labels, we have 13, we have 5, we have 12, and then we have 24 here. So are our two triangles similar? Remember our 3 theorems, and maybe you want to list these out. We have angle, angle, we have side, 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 and we have side, angle, side. Now remember, these are all for similarity, so maybe for the first couple of questions, you want to make sure you can list all 3 of these out. Now what I'm noticing is if we have two triangles that are within one another, right, there's going to be an angle that's shared. So for example, if you look in this diagram, this angle C here is a part of both of our triangles. So we can go ahead and label that in our separated diagrams as well. And again, this is generally going to be the case. You're going to have a shared angle when triangles are within one another. So another diagram where you might see that is if this was rotated around a little bit, right? This top angle here is going to be in both triangles. So taking a look here, right? In this smaller triangle, I have a lot of info. I might be able to use any of the 3 just with this triangle, but we need to have that information in both, right? So I can't use side, side, side. Even though I have information about all 3 of these sides, I don't know enough about triangle ABC here to say that all 3 sides are proportional, right? So we can't use that. Now, same thing here, right? For side, angle, side, I need information about at least 2 of our sides, right? So if I compare this bottom side, if I compare DC to AC, I can see that there's a scale factor there, but again, we can't conclude that the other sides are just as proportional because we don't have any information about any other side. So we can't use side, angle, side, but we can use angle, angle. I have 2 pairs of corresponding angles being congruent, so we can use angle, angle similarity to say that triangle ABC or BAC is similar to triangle EDC. All right, next example. This is another one that we were talking about, right? So reflexive property here, right? I can see you don't always have to separate, but it's always a good habit to separate both of your triangles to see this. But this top angle here, I already know is going to be in both of my triangles, right? Now, we can see here, don't forget that this symbol means that we have parallel lines, right? So remember, if you go back to your notes, I said that when your triangles look like this, when there's one within another, this is where we're using our F or our corresponding angles. Now I can make these conclusions, right? I'm given that these lines are parallel. So here's one F. I know that these two angles are congruent. And then if I use this F, I have that these angles are congruent, right? So if we were to draw our triangles separately here, I know we don't have letters, but let's just call this A, B, C, D, E. So this will be triangle ABC. This will be the smaller one. This will be the larger one. So we have A, D, E. Carrying over our labels, right? We have that angle B was congruent to D and angle C was congruent to E. And then we can carry over our numbers as well. So AB is 10. AD is this whole thing, which is 15. BC was X, and then DE was 18. So here, right, we want to see our theorems are, we have one, we have angle, angle, we have side, 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 and we have side, angle, side. So let's check. So I actually have an abundance of information here. I can use angle, angle, right? I have all three pairs being congruent. We don't need all three, but we just have extra info, right? So we have at least two pairs of corresponding angles being congruent, so we can use angle, angle in this case to conclude that our two triangles are similar. We can't use side, 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 right? Because we don't have that all three pairs of sides are proportional. And we can't use side, angle, side either because we need information about two pairs of sides, right? So here, if we compare A, B, and D, F, we would be able to compare these numbers to see if they're proportional, but we would need to know what this X value is here. If we knew what this X value was, then sure, we can compare these two values to see if the scale factor is the same for both pairs of sides, and then we would have the included angle there, but we don't have enough info there. So here we're using angle, angle to conclude that they're similar. All right, now this is the other example that we saw when our triangles are kind of intersecting like this, right? So I know I'm gonna be using, I have my parallel lines, so here I know I'm using my Z angles. So again, we have one Z here that we can say angle E is congruent to angle A. You can also use the other Z, right, a backward Z, but we're not going to do that just yet. But I also want you guys getting in the habit of again, looking for those vertical angles, right? So we have vertical angles here. So just with this information, not even looking at the numbers right now, I know I can use angle, angle to conclude that the triangles are similar. Right, so angle, angle is the easiest one. So if you can get there, you won't even have to look at the side lengths. All right, so that's it. Make sure that you guys are reviewing the theorems and what they say and the conditions for those so that you are ready for our practice.